All right, this is Mr. Martin, and these are the video notes for section 1.4 for honors geometry. This is part 2 of the video. So we went through this example, and we were given two right angles, and we had a conjecture that, okay, if I have right angles, then they have to be congruent. And we actually proved that that was true. So remember our process here. If we prove the conjecture true, then it becomes a theorem. So now, from this example, we get theorem 1. So we're going to state what we had here in general terms. It would be if angles are right angles, then they are congruent. Okay? So congratulations, you have your first theorem of the school year. We'll use this one quite a bit. Again, we went through the whole process of proving this one was true, but we won't always. For theorem 2, I'm just going to tell it to you. We could prove it in a similar manner to what we just did, but we're not going to. So theorem 2 is similar. It says if angles are straight angles, then they are congruent. Okay? So we have two theorems now. We don't need to prove these ever again unless the problem says prove this theorem is true. Then you would do it. But I'm typically not going to ask you to do that on quizzes or tests. We may do that in class, or we may do that in the notes once in a while. So now when we move to example 2, and it says given angle S is a right angle and angle T is a right angle, we don't really need a picture. We could draw one if we want. So here's angle S. We could draw angle T like this. Okay, and we want to see how many steps this would be. So would it be 1 step? Would it be 2 steps? Would it be 3 steps? Would it be 4 steps? Would it be 5 steps? Pick one of those numbers and see if you're right. I am going to say this is going to be 3 steps. Now before, over here, it was 5 steps, but that was when we were proving the theorem was true. We already proved it's true. We don't have to do that again. So we're going to set up our statements and reasons. So here's my statements. Here's my reasons. Okay, I'm going to put my given information in the proof. So number 1, angle S is a right angle. And the reason I can put that in is that it's given to us in the problem, so we write given. Number 2, angle T is a right angle. The reason we can write that in the statements is that that's given. And number 3, I know, because we proved it already, that since S is a right angle and T is a right angle, that angle S is congruent to angle T, because now we're going to use our theorem. If angles are right angles, then they are congruent. Okay, so that's how we would use this. Now, something I want to touch on before we end this video here is this theorem is a conditional statement. It's in the form if this then that. But it's not a definition, it's a theorem. And we know that anytime we do the converse of a definition, it has to be true. That's a nature of a definition. It's reversible, meaning the converse is true. But let's take a look at the converse of this. So the converse of theorem 1 would be if angles are congruent, then they are right angles. So is this true? So if any pair of angles are congruent, then they would have to be right angles. Well, hopefully you can see that this isn't necessarily true. This is not always true. Okay? So what this tells us is that, so this would imply that not all theorems are reversible. Okay, I can write the converse of the theorem, but since the converse is not true, it's not reversible. Okay, so keep that in mind. Definitions, always reversible. The converse is always true. Theorems, sometimes they are, sometimes they're not. Usually if the converse is true, we would just make it a different theorem. So just keep that in mind. Again, if you're having trouble or if you have questions, make some notes in the margins of your paper here and make sure you ask me next time we're in class. And we'll see you soon.